Welcome to session excerpts from Keyhole Software's Retrieval-Augmented Generation and Spring AI presentation. Here's Keyhole CTO Jaime Niswonger.
I think this is probably the most approachable and most, in my opinion, valid use case for most of our clients is this RAG solution and the benefits they can get out of that. How do we get your private data into the LLM that can be used for reasoning, but not expose that to the world, right? We don't want to give our private data out to Anthropic and let them train on it because we don't want everybody having our either private or proprietary or whatever data, right? But we want to be able to reason on that data. And this kind of closes that gap. Right, retrieval, we're going to search for relevant data or context. We're then going to augment the prompt with that context. And then we're going to generate a response based on the prompt, including the context that was given. That's really all it is. This is the most important thing about LLMs, how they work. If you don't understand this, you don't understand anything about it. So basically, we need data that we can store the semantic meaning of so that we can do similarity searches, right? This is how LLMs work, is when I ask a question, it has to go search its vast array of information very quickly and find things that are relevant or similar to the thing I'm asking, right? And we need to do that in a way that's not just pattern matching or text search or index-based lookups, right? We need to do it in a way that we can capture the semantic meaning of something and find relevant semantic information that I can use to reason and answer. Essentially, it's turning chunks of data into these high-dimensional arrays of numbers, but it's turning these data fragments into numerical arrays. When it does this, it does it in a way that if I turn my car crash into that and my automobile accident into that, those vectors end up very close together numerically. They're multi-dimensional, right? The high dimensions, a lot of different directions things are going. But then once I do that, I can then search for similar things to this array, and then get results back very quickly. So think of them as coordinates that have the semantic meaning for a sentence. In our case, we're using text, so sentence, paragraph, documents, right? And similar pieces of content produce vectors that are close together in that dimensional space. So once I've created these vector embeddings, right, I've basically chunked up my data, I've embedded it, I need to store it somewhere, and that's where these vector databases come into play. They're just really specialized databases that can store these types of arrays, these multi-dimensional arrays, and they can very quickly do similarity searches with incoming vector embeddings, right? So if I say, how do I bake bread? It'll turn that into a vector embedding. It'll search into the database using that vector embedding. It'll get similar documents, similar embeddings back that then can be turned back into text that I can then use for reasoning. So, right, how do I take the data that I want to use in my reasoning and get it ready to use, right? This is the hard part of this whole process, right? Technically, it's not hard, but figuring out the right level to do it, how do I break my chunks apart? Do I overlap chunks so that I get more coverage of responses? There's just a lot to think about. How do I attach metadata to that so that, Dave and I are starting a project next week that they have Excel spreadsheets, they have PDFs, they have handwritten notes we're going to have to OCR, right? They got all this disparate data that's all related in some way, right? And we've got to store that in such a way that we can build those relationships with those chunks of data that are coming from different sources, and then we can look up information on it very quickly, right? That's the hard part of AI. That's the hard part of RAG. That's the hard part of all this. Technically very easy, and you'll see the code that I use to do my embedding. Technically very easy. The data science problem's the hard part, right? How do I break this down in such a way that I can actually use it effectively and get successful context retrieval? Oh, good, the fun part. But I'm going to build a little Python LangChain app. It's like 10 lines of code or 20 lines of code where I'm creating my own little world, right? I'm creating the Keyhole universe. You'll see down here that, and I want to query about these things, but I want to use OpenAI to do it. OpenAI knows nothing about Keyhole universe, right? So I can ask questions about the Keyhole universe using OpenAI using this kind of model. I've got these documents here, right? And it's the ones I showed in the slide. And that's it. That's my universe of data that I have to supply to this thing. And then I want to be able to ask questions. And then I'm going to use OpenAI, chat OpenAI AI right here is my link in Python, my API in Python to do that. I'm just going to ask it that question and then print out the results. And if I ask this question in ChatGPT, it tells me not necessarily a hallucination because the world it's talking about is our world, right? But it's incorrect for the context that I'm living in, right? I can give these LLMs context to what I want to search and let it reason on my context versus me having to do text search, any kind of semantic implementation myself, right? It'll just do it for me based on the context that I give. This is the prompt that I create to actually send over to OpenAI. As I say, use the following context to answer the question, and don't answer if you can't determine it from the context. There's a whole discipline around this prompt engineering, right? But this is a very simple example of I can tell the LLM what to do in certain cases, and it will honor that, right? If I don't put that in there and I ask about a purple planet, it might make up some kind of answer about give me a different result instead of explicitly, I don't know based on what you've given me, right? Which in a lot of enterprise cases is going to be the case. Don't make up something. Don't try to guess. If I don't give you the right context, tell me you don't know so that I can react appropriately, right? Now, there's probably use cases that fuzziness helps, right? Where it's a combination of my context and the LLM's model that would give me good answers. But a lot of times in enterprise cases, it's not going to be the case.
Interested in a deeper dive? Keyhole offers this full presentation to enterprise development teams, exploring AI and custom development solutions. Learn RAG core concepts and why it's critical for enterprise AI adoption. See Spring AI in action and how it simplifies connecting LLMs with vector databases. Book a session today. Expert consulting, knowledge transfer, Keyhole Software.